Could the dream of developing a Star Trek warp drive be a possible end to our civilization? We've all seen the USS Enterprise leap into warp speed with an easy, graceful flash of light. But physics suggests that the testing phase of developing such a powerful technology may be the doom for our species. We're talking about a technology that could tear a hole in space-time itself just to find out whether we can move an inch. Before we ever reach Tau Ceti or Alpha Centauri, we might just accidentally tear a hole in space-time, right in our own backyard. The warp drive is the ultimate symbol of human optimism. A technology that turns the enormous vast distances of the cosmos into a place we can finally explore. But if we strip away the Hollywood fantasy and apply the brutal laws of reality, the path to reaching that final frontier looks less like a dream and more like a planetary-scale disaster. Before we ever harness the power of a warp drive, we have to survive the testing phase. The testing phase could be the end of our entire civilization as we know it. The reality is, we don't know what repeated failed attempts at creating a stable warp bubble would do to space-time, or what its effects would be. Even attempting the creation of a warp bubble would require staggering amounts of energy and the mastery over negative energy. Assuming such a thing can exist beyond theory. Imagine the pre-Captain Kirk era. We're not building magnificent starships. We're building massive, volatile prototype reactors in the middle of our own backyard. To create a warp bubble, you have to bend and manipulate space-time itself, contracting it in front of a ship while expanding it behind. It's a fundamental assault on the structure of the very fabric of reality and of existence itself. To create a warp bubble, even on smaller scales, requires exotic matter, a material with negative energy density that may not even exist in our universe. The first tragedies would be silent, sudden, and horrific. Imagine the first tests occurring in a remote desert laboratory, or on a space station dangerously close to Earth. An early experiment with a micro-warp field fails. We aren't talking about a conventional fireball. We're talking about a localized space-time anomaly. In a fraction of a second, the entire facility doesn't explode. It simply ceases to be. It dissolves into pure radiation, or even crushed into a microscopic black hole that evaporates instantly in a lethal burst of Hawking radiation. We lose our most brilliant minds, our best engineers, and the collective hope of a generation, all in a single terrifying flash of light that leaves no wreckage behind. As the tests begin to scale up, the brutal reality becomes an economic death spiral. To fuel even a fraction of a warp bubble, you need antimatter, one of the most expensive and dangerous substances in the known universe. In the Star Trek universe, dilithium crystals serve as a fictional mechanism for regulating the reaction. But today, in the real world, we have no such Hollywood safety net. Producing a single gram of antimatter would cost trillions of dollars and could quite possibly consume the entire power output of our entire planet. Every time a prototype nacelle cracks or a containment field flickers, the GDP of a superpower evaporates. We would be forced into a warp race that makes the Cold War look like a school project. Imagine a world where we stop funding medicine, education, and climate repair just to throw more resources into the financial pit of developing a warp drive. We could see a global economic collapse where civilization fractures into warring factions, fighting over the leftover scraps of a world that bankrupted itself, trying to build the impossible. Similar to how ancient Egypt almost did in building the pyramids. Space isn't just an empty room, it's a fabric. And every time we fail a warp test, we may be taking a pair of scissors to that fabric. Unstable and unsuccessful tests could leave behind warp remnants. Localized space-time distortions where gravity behaves in unpredictable ways. Time begins to dilate, and the laws of physics no longer behave as they should. If a test goes catastrophically wrong too close to Earth, we could inadvertently create a gravitational ripple that destabilizes the Moon's orbit, leading to catastrophic tidal waves that redraw our coastlines. Or worse, a high-energy tear in space-time could strip away our atmosphere, leaving us breathless on a now dying planet. We could be playing with the fundamental forces of the universe, like toddlers playing with a blowtorch in a house made of paper. Tragedy after tragedy would become the new normal. We could even see ghost ships trapped in partial warp fields, frozen in time, visible from Earth but unreachable. A permanent, glowing reminder of our arrogance. Our fascination with the stars could give way to a deeper fear of the cosmos once we understand what could happen if we try to manipulate it. The path to the stars has to go through an extensive and dangerous testing phase that we may not be equipped to survive. Nature is a game of patience and unimaginable power. The price of bending the universe to our will may be the end of our very existence as a species if we even try to do it. The dream of achieving Warp Factor 1 may result in nothing less than the complete destruction of not only our world, but our entire solar system, the only one we've ever known. It could be that the universe and its laws have been designed to ensure that intelligent species never get a chance to meet. If this is true, then tampering with the very fabric of space-time could be our undoing.